According to Article 348 of the National Electrical Code, flexible metal conduit, also known as greenfield, can be used for service feeders under certain conditions. Within buildings, flexible metal conduit can be used indoors for service feeders where the conductors are protected against physical damage and the ambient temperature does not exceed 120 degrees Celsius. Flexible metal conduit must be installed in accessible locations where it can be inspected and maintained. Flexible metal conduit can be concealed within walls or ceilings if it is protected against moisture and corrosion. Flexible metal conduit is available in trade sizes up to 4 inches. The maximum number of conductors allowed in flexible metal conduit is determined by its trade size. When considering flexible metal conduit for service feeders from remote disconnects to panels, several factors need to be evaluated. The distance is one factor. Consider a distance of approximately 30 feet, which is within the allowable range for flexible metal conduit. Accessibility is another factor. If the flexible metal conduit will be concealed within the wall, it should be able to be accessed through the panelboard enclosures. Physical protection must be ensured. Flexible metal conduit needs to be protected within the wall from physical damage. The ambient temperature is another point to consider. The ambient temperature should likely be below 120 degrees Celsius. Lastly, there are size limitations. The conductor size required is 3/0, which is available in flexible metal conduit trade sizes up to 2 inches. Based on the requirements of Article 348 and the specific conditions, it is permissible to use flexible metal conduit for the service feeders between the disconnects and the panels. However, you should carefully evaluate all the factors mentioned above to ensure that the flexible metal conduit is installed in accordance with the National Electrical Code requirements. It is also advisable to consult with a qualified electrician or local authority having jurisdiction for final approval. To further clarify the appropriate application of flexible metal conduit, let's delve deeper into each of the considerations. Firstly, regarding the distance of 30 feet, it's crucial to remember that while this falls within the general acceptable range, the National Electrical Code emphasizes minimizing the length of any flexible conduit runs. Longer runs increase impedance, which can affect voltage drop and overall system performance. Therefore, always strive to use the shortest practical length of flexible metal conduit to meet the installation requirements. Secondly, accessibility is not just about being able to reach the conduit after installation. It also implies ease of inspection and maintenance. Consider how the flexible metal conduit run will be supported within the wall cavity. Ensure that it's not subject to undue stress or strain, which could lead to damage over time. Furthermore, provide adequate access points, such as pull boxes or junction boxes, at appropriate intervals to facilitate future troubleshooting or conductor replacement. Thirdly, physical protection is paramount. While the wall itself offers a degree of protection, consider the potential for damage from other sources, such as nails, screws, or even rodents. In areas where the flexible metal conduit is exposed to such risks, additional protective measures may be necessary, such as encasing the conduit in a rigid sleeve or using a heavier gauge of flexible metal conduit. Fourthly, the ambient temperature rating of 120 degrees Celsius is a critical safety factor. Exceeding this temperature can degrade the insulation of the conductors within the conduit, leading to short circuits or even fires. Be mindful of potential heat sources near the flexible metal conduit run, such as lighting fixtures, transformers, or other heat-generating equipment. If the ambient temperature is likely to exceed 120 degrees Celsius, consider using a different type of conduit or taking steps to reduce the temperature. Fifthly, size limitations are not solely determined by the conductor size. The fill capacity of the flexible metal conduit must also be considered. The National Electrical Code specifies the maximum allowable percentage of the conduit's cross-sectional area that can be occupied by conductors. This ensures adequate space for heat dissipation and prevents damage to the conductors during pulling. Refer to the appropriate National Electrical Code tables to determine the correct conduit size for the number and size of conductors being installed. Beyond these considerations, it's also important to address grounding and bonding requirements. Flexible metal conduit itself is not recognized as an equipment grounding conductor. Therefore, a separate equipment grounding conductor must be installed within the conduit to provide a low impedance path for fault current. This conductor must be properly sized and connected to the equipment grounding system to ensure effective ground fault protection. In addition to the National Electrical Code requirements, local codes and regulations may impose additional restrictions or requirements on the use of flexible metal conduit. Always consult with the local authority having jurisdiction to determine the specific requirements for your installation. Finally, proper installation techniques are essential for ensuring the long-term reliability and safety of the flexible metal conduit system. Use only approved fittings and connectors that are specifically designed for use with flexible metal conduit. Ensure that all connections are tight and secure to prevent moisture ingress and maintain electrical continuity. Support the flexible metal conduit at appropriate intervals to prevent sagging or strain. And always follow the manufacturer's instructions for installation. In summary, while flexible metal conduit can be a viable option for service feeders in certain situations, it's crucial to carefully evaluate all the relevant factors and adhere to the National Electrical Code requirements and local regulations. By doing so, you can ensure safe, reliable, and code-compliant installation. Furthermore, consider the potential for future modifications or additions to the electrical system. Designing the flexible metal conduit installation with flexibility in mind can save time and money in the long run. For example, leaving extra space in the conduit for future conductors or providing additional access points can make it easier to accommodate future changes. Moreover, document the flexible metal conduit installation thoroughly. Keep accurate records of the conduit routing, conductor sizes, and grounding connections. This documentation can be invaluable for future troubleshooting or maintenance. In addition to the technical considerations, it's also important to address the aesthetic aspects of the flexible metal conduit installation. While functionality is paramount, a neat and professional-looking installation can enhance the overall appearance of the building. Take care to conceal the flexible metal conduit whenever possible and to use appropriate supports and fasteners to maintain a clean and organized appearance. Finally, remember that electrical work can be dangerous. Always take the necessary precautions to protect yourself and others from electrical shock. Wear appropriate personal protective equipment such as gloves and safety glasses. To energize the circuit before working on any electrical components. And never work alone. By following these safety guidelines, you can minimize the risk of accidents and injuries. In conclusion, the use of flexible metal conduit for service feeders is a complex topic with many factors to consider. By understanding the National Electrical Code requirements, local regulations, and best practices, you can make informed decisions and ensure safe and reliable installation. Remember to consult with a qualified electrician or local authority having jurisdiction for final approval and to always prioritize safety. Now, let's consider some specific scenarios where flexible metal conduit might be particularly well suited for service feeders. Firstly, in existing buildings where it's difficult or impossible to install rigid conduit due to physical obstructions or space constraints, flexible metal conduit can provide a flexible and adaptable solution. Its ability to bend and flex around obstacles makes it ideal for navigating tight spaces and complex geometries. Secondly, in applications where vibration or movement is a concern, flexible metal conduit can help to absorb these forces and prevent damage to the conductors. Its flexibility allows it to move with the structure without putting undue stress on the connections. Thirdly, in temporary installations or applications where the electrical system may need to be reconfigured in the future, flexible metal conduit can provide a convenient and reusable solution. Its flexibility allows it to be easily relocated and reconnected as needed. However, it's important to note that flexible metal conduit is not always the best choice for service feeders. In some situations, rigid conduit may be a more appropriate option. For example, in areas where the conduit is exposed to severe physical damage or corrosive environments, rigid conduit may provide better protection. Similarly, in applications where a high degree of electrical shielding is required, rigid conduit may be a better choice. Ultimately, The decision of whether to use flexible metal conduit or rigid conduit for service feeders depends on the specific requirements of the installation. A careful evaluation of all the relevant factors is essential for making an informed decision. In addition to the type of conduit, the choice of conductors is also an important consideration. The conductors must be appropriately sized for the load and must be rated for the voltage and temperature of the application. Furthermore, the conductors must be compatible with the conduit material to prevent corrosion or other damage. When selecting conductors for use in flexible metal conduit, it's important to consider the ampacity dirting factors specified in the National Electrical Code. These factors account for the effects of heat buildup in the conduit and reduce the allowable ampacity of the conductors accordingly. Failure to apply these dirting factors can lead to overheating and potentially dangerous conditions. Another important consideration is the type of insulation on the conductors. Some types of insulation are more resistant to moisture, heat, and chemicals than others. Choosing the right type of insulation can help to ensure the long-term reliability of the electrical system. In addition to the technical aspects of the installation, it's also important to consider the cost. Flexible metal conduit is typically more expensive than rigid conduit, but it can often save time and labor during installation. A careful cost-benefit analysis can help to determine the most economical solution for a particular application. Finally, it's important to remember that electrical work is not a do-it-yourself project. It requires specialized knowledge, skills, and tools. Always hire a qualified electrician to perform electrical work to ensure that it is done safely and correctly. A qualified electrician will be familiar with the National Electrical Code, local regulations, and best practices for electrical installations. They will also have the necessary insurance and licensing to protect you from liability in case of accidents or injuries. By hiring a qualified electrician, you can have peace of mind knowing that your electrical system is safe, reliable, and code compliant. And with that, this discussion on flexible metal conduit has come to an end. Keep in mind that there are many different factors to consider and adhering to safety guidelines is important, so consulting with a professional can be beneficial.